Hello everyone. Today let's solve the problem number 42, trapping rainwater. So you can just go through the question and you can go through the example as well, so that you'll understand the question pretty well. So I'll just summarize the question so that it will be easier to understand, right? So what the question states here, we are given an elevation map where the width of each bar is 1 here. We are given an elevation of this one elevation map where the width of each bar will be 1. Width they are speaking of. Width of each bar is 1 unit, and the array represents the height of each bar, and the array represents the this one height of each bar. What is our main task? Basically, the task is to compute how much water will be trapped after it rains given the elevation, right? So let's come to the example here. We have to calculate how much water will be trapped after it rains given the elevation, right? So I hope the question is clear. So let's come to the this one example. Here they have given array of this thing here. Array represents height of each bar right here. So they have given this number within the array. So here you can clearly see the output that we have got here is 6. Why? Here the water that it can trap after raining here is 6. Basically this is 1 and this is 2. Let me put line here. This one will be 3 and this one will be 4, and let me close this one, and this one is 5 and this one is 6 basically. So the output that we got here is 6. Just give me a second here. So they have clearly explained here as well. The above elevation map black section that is represented by the array. This one you can clearly see, this one they are speaking of, and in this case 6 units of rainwater. Blue section, this one as I have showed, this one are being trapped. Same goes with the example 2 as well. You can just check for the example 2 as well. So initially what we'll do, let's go with the approach and let's see all the edge cases, then let's write the code and discuss the complexities, right? So initially let's discuss we need to calculate the trapped water by comparing the heights of the bars on both ends of the elevation map, right? So let's make use of the two-pointer approach here. Again, I'm telling we have to calculate the trapped water by comparing the heights of the bars on both ends of the elevation map. That is the reason let's go with a two-pointer approach, right? So the approach that we'll be going here is 2 pointers, or I'll just give you 2 pointers. This is fine. And let's discuss the approach step by step. So we have to initialize the 2 pointers, right? So what I'll do initially, let's start with the 2 pointers, nothing but left and I'll just be going with left and right pointers, right? So left, let's assign to the start or beginning of the array, and right, let's assign this one to the end of the array, right? So this is what this is the first step. And second thing is, while I say start, this has to point to the index 0 and this has to point to the array length -1. I'll just give here let me give a length -1, array length -1. This has to be right. So this is the first step, and we have to keep track of the maximum heights seen from the both left and right. Nothing but left, if I have considered here left max and right max, suppose we have to keep track of the maximum heights seen from both left and right, nothing but the L max and right max. This is fair. And finally we have to keep a water variable to accumulate the trapped water. So we need some variable, right, to accumulate the total trapped water. So let's go with the water. Let's make use of the water variable here. Let's make use of the water variable here just to we have to keep a water variable to accumulate the total trapped water. So let's move to the second step, nothing but move the pointers here. So I'll just give here move the pointers. We have to move the left and right pointers, right? So while the left pointer is less than right pointer, while I say this one, left less than right pointer, we have to compare the heights at both ends. If the height is L, if the height at L is less than height at R, we will focus on the left side. So left less than right, then we will focus on the left side. Then if the uh, suppose height of L is less than height of R, we will be focusing on the left side. And if the height of L is greater than height of R, then we will be focusing on the right side. That's what we'll be doing here. So let's come to the main step, nothing but calculating this one, trapped water. So here, this is the main step, right? At each step, we will be calculating the trapped water based on the current bar's height and the maximum height seen so far. Nothing but we have considered L max and R max, right? So if you remember initially, so here, let me come here, this one. So what we are doing here, at each step, we will be calculating the trapped water based on the current bar's height and the maximum height that is seen so far. Nothing but L max and R max. Finally, the final step is we have to update the maximum height, right? So here, this one will be update max height, final step. So what we will do here, we will continually update the maximum heights as we progress through the array. This is the final step, right? This is the approach that we'll be going with. Next, let's discuss all the edge cases. Then let's write the code and discuss the complexity. Let's discuss the edge cases one by one. I'll just give here edge cases. So what we'll do, let's go with the first edge case. Nothing but so array with the single element. So let's consider the example here, array with a single element, right? Let me consider some random number here, 5. Let me give 5 here. So here the output has to be 0. Why the output is 0 here? We know that no water can be trapped if there is only one bar. If there is only one bar, then no water can be trapped, right? So this is one first edge case. So I'll just come here and give array with a single element or one element. This is fine. This is easy to understand, right? The second one, let's go with array with all the bars having equal height. So let me consider example here. This one. Anything you can give here. I am just considering array with all the bars having the equal heights. So here the output will be 0 as well. Why the output will be 0 here? Because we know no water can be trapped since there are no values at all. So here there are no values at all, right? So no water can be trapped here. So this is the second edge case. Nothing but array with all bars having equal heights, right? This is fine. This is for the second edge case. Next, let's move on with the third edge case. So this one is for the array with decreasing heights, right? So I can just take the example here, 5, 4, 3, 2, 1. So let me consider this example. So here also the output will be 0 itself. Why? We know that no water can be trapped if the bars keep decreasing in height from left to right. The water will get spilled outside, right? So no water can be trapped here if the bars keep decreasing in height from left to right. Also, we have to keep in mind, even the heights are increasing. Array with the decreasing heights as well as the array with the increasing heights, the water will get spilled outside. So no water can be trapped, right? So we know this one. So I'll just come here and give array with decreasing heights. This is fine. This is third one, third edge case. Fourth edge case is as we had discussed earlier, this one, array with the increasing heights. I'll just give here. Previous one was for the decreasing heights, right? This time we'll go with the array with increasing heights. So I'll just give here. For this also the output will be 0. Why? Because previously, similarly, similar to the previous one, previous edge case, no water can be trapped if the heights are increasing because the water gets spilled outside, right? So this is one thing, array with here increasing heights. So this is one thing. This is the fourth edge case. And the final one, let me come here. Final one, we have already discussed in the example. So this is example. We have already seen the example one, right? So just give me a second here. So this one I'm speaking of 0, 1. The output will be 6 here, right? So I have already explained this one. This is the fifth edge case. So just give me a second. So what are the edge cases that we have discussed now? Array with a single element, array with all the bars having equal heights, and array with decreasing heights, array with the increasing heights, and finally the example one, right? Array with all the numbers, right? So then next what we will do, let's start writing the code. I'll explain the code. I'll just explain the code while writing the code itself, right? So initially what I'll do, as we had discussed in the approach, so let's start initializing the left and right pointers, also max heights along with the water count. So this is easy. Let me give here. This is left. I'll just consider L. This is right. This has to point to the final, this one, last index, nothing but array dot length minus 1. And we have to consider this one, maximum heights and as well as the water count, right? So for the maximum heights, we know that I'll just consider L max. This one, let me initialize this one to the 0. Also R max, let me initialize this one to the 0. Finally, water count, I'll just initialize this one to the 0 as well. So while the left pointer is less than the right pointer, will further continue, right? So left pointer has to be lesser than the right pointer. This has to be true at any cost, right? So if the height at the left pointer is smaller than the right, then we have to update the left maximum height. We have already discussed this one during the approach. Again, I'm telling, just keep in mind, if the height at the left pointer is smaller than at the right, then we will be updating the left maximum height. So how can we write that? A simple if condition, right? So this one will be array of left, this one less than array of right. Then what we will do here, we will update the left maximum height. Also we have to calculate the trap water at the index left at that case, right? We have to calculate the left, we have to calculate the trapped water at the index L at that point of time. So again I'm telling, just keep this in mind. If the height at the left pointer is smaller than at the right, then we will update the left maximum height and then we will calculate the trapped water at the index L. If the height at the left pointer is greater than at the right, then what we will do, we will update the right maximum height and we will calculate the trapped water at the index R. That's what we'll bring. Two simple steps, right? So I'll just come here. Let me give L max. This one we have to calculate the trapped water. We have to update the left maximum height first, right? For that, I'll just consider here mat.max L max, comma, array of L. So through array R, array of L, whatever I have written, we will get the maximum height, right? Then we have to calculate the trapped water at the index L. For that, I'll just give here, we have considered water, right? Water equals water plus L max I have considered. This M has to be capital right here. Minus array of L. This is fair. Finally, what we will do, we have to move the left pointer to the right. For that, let's increment the left pointer here. This is fine. Else, the second condition is if the array of L is greater than the array of R. Same thing we'll be doing. But instead of this thing here, will be instead of updating the left maximum height, we'll be updating the right maximum height and we'll calculate the trapped water at index R. And finally, we will move the right pointer to the left. instead of moving the left pointer to the right, we'll be moving the right pointer to the left. So I'll just give here R max. So I'll just copy the same thing here and make the necessary changes. Let me copy this one very quickly and make the necessary changes. Here this one has to be R max, math.max of this one instead of array of L, this one will be array of R. This is fine. And what are this one will be same. Instead of L max, this will be R max and this will be array of R. So we are calculating the trap rotor at the index R here, right? This line number 11. And finally, line number 12, instead of moving the left pointer or left pointer to the right, or instead of incrementing the left pointer, we have to decrement the right pointer or move the right pointer to the left. So I'll just come here, I'll just give here R minus minus. This is simple. The final step is we have to return the total trapped water. I just give here return water. So let me format this one once. Let me hit the run. So this is it for the code. So why we are getting the wrong answer here? Let's check what we have done wrong here. So here in the line number 10, this has to be right max. So we are considering for the this one array of L greater than array of this one R, right? So I just copy pasted this one. I forgot to change this one, I think. So let me run the code again. Let's see whether this works or not. So now you can clearly see here the sample test cases are getting accepted. Let me hit the submit button now. So now we can clearly see here the code got accepted, right? So this code works absolutely fine. Let's quickly discuss about the time complexity and the space complexity, right? So what will be the time complexity and the space complexity here? The approach that we went with here is a two-pointer approach, we know, or the sliding window, basically, right? So what will be the time complexity and the space complexity here? The time complexity here will be big O of n, right? So what will be the space complexity? So the space complexity will be big O of 1 here. So just let me give here the time complexity will be big O of n and the space complexity will be big O of 1. So why the time complexity here is big O of n? Because we are traversing the array using once using the two pointers. We are traversing the array once using the two pointers. And why the space complexity here is big O of 1? Because we are making use of the constant amount of extra space and few variables here, right? So the space complexity would be big O of n and that overall time complexity would be, the overall time complexity would be big O of n and the overall space complexity would be big O of 1. So yeah, this is it. Thanks for watching, guys.